Okay, so let's graph let's graph another function. So let's say we have f of x equals x squared plus 3x minus 6. Okay, so let's go ahead and draw our Cartesian coordinate system. I do not know why I'm not getting good focus here. Okay, that's better focus. Okay. So assume we have x squared plus 3x minus 6. That's our function. Here's our Cartesian coordinate system. The first thing we do, solve for f of 0. That equals negative 6. Okay? So when x is 0, y is negative 6. Okay? Now, what happens when y is 0? Well, when y is 0, then we plug this quadratic function into the quadratic formula and solve for x. That gives us x equals negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times a, which is 1, times c, which is negative 6. All that is divided by 2a, which is 2. And so x equals negative 3 plus or minus the square root of, let's see, that's 24, 33, divided by 2. Okay, and if I'm not mistaken, you can use your calculator and figure this out, but if I'm not mistaken, this means x equals approximately 1.372, or x equals approximately negative 4.372. Okay, so we have 1.372 and we have negative 4.372. Okay, so once again, we're dealing with a symmetric function here that's coming down. It's going to be U-shaped. Question is, where is the axis? We know it's going to be to the left of the y-axis because it's a symmetric function, right? If it's U-shaped, the axis is going to be somewhere to the left of that, meaning that the lowest point on the function, the vertex, is going to be below negative 6. Okay, so where exactly is that? Well, it's going to be halfway between these 2 points. Now, what we can do is we can take then, so we're negative 4.37 units away from the y-axis. We can take 4.372. We can add to that 1.372, and that gives us 5.6. Was that? Hold on a second. Let me break up my calculator on that. That would be 4.372 plus 1.372. There you go. That is 5.744. Okay. Now we can. So that is the total distance from here, this intercept to that x-intercept. Okay. That's the total distance is 5.744 units. If we divide that by 2, we get 2.872. Okay, now what do we do with this? Well, we can either subtract this from 1.372 or we can add it to negative 4.372. So let's subtract it from here. So that gives us 1.372 minus 2.872. And that gives us negative 1.5. So the axis, the point right smack in the middle, is negative 1.5. Now we need to find the y-coordinate of the vertex, and we do that by plugging the negative 1.5 back into the function. So now we're going to solve for f of negative 1.5. That gives us negative 1.5 squared plus 3 times negative 1.5 minus 6. So that gives us 1.5 squared. 2.25. It's positive because I'm squaring a negative, which gives me a positive, minus 3 times 1.5 equals 4.5 minus 6. So this is 2.25 minus 4.5 minus 6 equals negative 8.25. So that's the y-coordinate of my vertex, negative 8.25. Okay, so this, so right somewhere right in here, that's going to be my minimum. Okay, that's going to be the lowest point on that curve. So this curve looks like this. Let's do another one. What if we have a function that looks like x plus 6 squared? Let's draw our Cartesian coordinate system. Now, you know, we could FOIL this out, but really it's not necessary, and here's why. Because when we solve for f of 0, what do we get? Well, we get 36. Okay, so when x is 0, y equals 36. Okay, here's something unique, however. When we set y equal to 0, that gives us x plus 6 squared equals 0. Well, we can solve this right out. There's no need to put that into a quadratic formula. How can we solve it right out? We take the square root of each side. Okay, so if I take the square root of this and the square root of this, what's the square root of 0? It's 0. What's the square root of this? X plus 6. So x plus 6 equals 0, x equals negative 6. But we have no other x points. Aha, what does this mean? Well, this means the only 2 points on this graph that we can work with are 36 and negative 6. This means negative 6 must be our vertex. 36 must be an intercept. So this function is actually easier to solve for than the last one. Although you have to use slightly more imagination in drawing it. That's the only way that function can look, and that is the way that function looks. I only have one x to deal with, so it must mean that that function touches at that one point on the x-axis, and that's it. So that's the only way this function can look. Let's do another one. What about f of x equals negative x squared plus 3? What if we have a function that looks like that? Well, I'm going to solve for f of 0. That equals 3. Okay, so when x is 0, y is 3. Okay, so that point's going to come into play. Now, how do we solve this? Again, we don't need the quadratic formula because we don't have a proper quadratic function. What do we have? Let's see. When we set y equal to 0, we get negative x squared plus 3 equals 0. This means negative x squared equals negative 3. We can divide through by -1 or multiply through by -1, doesn't matter. This gives us x squared equals 3. This means x equals plus or minus the square root of 3. And what is the square root of 3? Well, let's see. My trusty calculator says it is 1.732, so x equals 1.732, or x equals -1.732. So here's 1.732, there's -1.732, and this function must look like this. Let's do another one. How about, let me get another one here. How about f of x equals -x squared plus x plus 2. Okay, so let's draw our Cartesian coordinate system here. So we solve for f of 0, that equals 2. So when x is 0, y is 2. We do have a proper quadratic function here, so we can go ahead and plug that into our quadratic formula. So x equals -1 plus or minus the square root of 1 squared, which is 1, minus 4 times a, which is -1, times c, which is 2, all divided by 2a, which is -2. So x equals -1 plus or minus the square root of, what is that, 8, 9, divided by -2. So x equals -1 plus 3 divided by -2, which equals, let's see, that is 2 divided by -2 is -1, or x equals -1 minus 3 divided by -2, which equals -4 divided by -2, or 2. Okay, so when y equals 0, x equals 2, or -1. Now notice here, this is going to be an upside down u, okay? And because, again, it's symmetric, the axis here is going to have to lie to the right of the y-axis. Or the axis of the function is going to have to lie to the right of the y-axis. By how much? Well, we have 3 units between -1 and 2. So we have -1 to 0, that's 1 unit. 0 to 1, that's 2 units. 1 to 2, that's 3 units. Divide that in half. That is 1.5. We can subtract 1.5 from 2, and that means our axis is at -0.5. Now we need to find the y-coordinate of the vertex, and so we would plug -0.5 into the original function, and we would get -0.5 squared. Notice, excuse me, I'm sorry. You know, for some reason I had the problem we did earlier on my mind. That is not -0.5, it is 0.5. Duh. Let me get rid of this negative sign. So this would be -0.5 squared. Now notice what I did here. This is a -x squared, okay? So x is 0.5, okay? So I'm not going to get, I'm going to get a negative value out of this now, even though 0.5 is squared. Just keep that in mind. Be careful when you're working with, when you're plugging back in to these functions. Minus, or plus, excuse me, 0.5 plus 2. So that gives us, okay, so 0.5 squared is 0.25. That gives us negative 0.25 plus 0.5 plus 2. That plus that is 0.25. That would be 2.25 is the y-coordinate of the vertex. Okay, so that is about right there. That's where the top of this function is going to be, and it's going to come down like that.